In this video we are going to discuss interoperable standards and open source software for spatial data infrastructures. As discussed in the previous video, GIS users tend to develop their own datasets on their own desktop computers with desktop GIS, which might not be the best way, and therefore we have introduced the concept of spatial data infrastructures. But GIS users generally might not know what available existing datasets are out there. Also, the access to these datasets can be very difficult. It's also not in the culture to share datasets with other sectors or organizations. And the data is often stored in certain formats and systems that cannot be easily exported to other systems or other software. We know, however, that data collection costs are relatively high compared with the cost of GIS hardware and software, especially if we use open source software. So there's a lot of duplicate efforts going on, while cost can be reduced by using SDI. In this lecture, we'll introduce you to the concepts of open standards and open source software. After this lecture, you are able to describe the challenges with integrating spatial data, describe the most used Open Geospatial Consortium standards, describe why interoperable standards are important, and explain the advantage of using open source software. And describe the software components that are used in an SDI. If we deal with data, and especially spatial data, there are incompatibilities in formats and data models. Another challenge is that there is missing documentation or metadata about the data. In the next video we'll explain more about metadata. Also, data is very much fragmented and there's a lot of replication, so it's very hard to find the original source, for example for administrative boundaries, which can bias statistics. And we also have to deal with data policies. We will cover that aspect in the last video of this series. So we have to look at interoperable system aspects. The first aspect is technical. How do different machines communicate with each other? Sensors with servers, different servers with each other, servers with desktop software, and commonly we use APIs for that, application programming interfaces, to deal with different formats and different schemas and make them more compatible. Another aspect are semantics. We need a common understanding using common concepts and terminology, and often there's interdisciplinary special vocabularies that we need to be aware of. For example, people dealing with water quantity have different terminology than people dealing with water quality. Another aspect is legal. We need to know the different rights of using the data, the ownership, responsibility, and copyrights. The final aspect is human. To work together and to share data, we need cooperation and collaboration, and above all also training, so people are aware of the advantages of cooperation. In this lecture we'll cover the technical parts, and in the technical part we in fact need a universal adapter. Like with power plugs, we're not going to ask the whole world to change their power plug to fit to one type, but we have a special device, the universal adapter, that makes it possible to connect different power plugs. And that's much easier than adapting all the power plugs in the world. And we can do the same with GIS data and communication between software and servers and sensors. The standards that we use in SDI are maintained by the Open Geospatial Consortium. The OGC is a not-for-profit organization focused on developing and defining open standards for the geospatial community to allow interoperability between various software and data services. The OGC standards are developed by members to make location information and services fair, findable, accessible, interoperable, and reusable. They are used by software developers to build open interfaces and encodings into their products and services. Here we see the most important OGC standards for spatial data infrastructures, also called OGC services or APIs. The web mapping services, or WMS, are a rendered image of the data. So it's not the real data, points, lines, polygons, or raster, but it's a picture generated from the data for visualization in web apps, mobile apps, or services. There's also the Web Feature Services, or WFS. That gives access to vector data. It's not a rendered picture, but it gives access to points, lines, and polygons, including their attributes. We have a similar web service for rasters, which is called the Web Coverage Service, or WCS. With these standards, we can exchange data between servers, desktop software and servers, mobile applications and servers. There are also standards to share metadata, the CSW or catalog services for the web, and even processing tools through the Web Processing Service or WPS. There are some big advantages of using open standards. For example, we can nest SDIs. The ones at institutional level can be connected to the sector or the region, and the regional ones can be aggregated to the national level, continental or global levels, where the data still remains the same but is accessible through the spatial data infrastructure and the open standards, and are accessible in an easy way. Another advantage is that we can look at the same data with different tools. So here we see the global cyclone dataset, and it is visualized using a desktop GIS, a web portal, or Google Earth. And if anything changes in the data because of its accessibility through a spatial data infrastructure, all the software will look at the same data all the time, which is much better than having outdated copies on different servers or hard disks. We've seen this demonstration before, but now we're going to focus on the open standards that are used here. So we connect with QGIS here to the SDI. It's a GeoNode. And when we click connect, we see all the layers that are available, but in the right column we see the web service WMS, Web Map Service, or WFS, Web Feature Service. And if we choose WMS, like in this case, we will get a rendered picture of the data. If we would have chosen WFS, we would get access to the polygon of the catchment boundary in this case. And then we can further edit and process it. So it depends on your purpose which standard you use. If it's only visualization, WMS is good enough. If you really want to edit and interact with the data, you need a WFS for vector data and WCS for raster data. So through these standards, we can connect our desktop GIS with the spatial data infrastructure and exchange data. The same can be done with decision support systems or models. Open standards are supported by open source software because it provides better interoperability between components, and they use the international OGC standards. With proprietary software it's different. They try to lock you in, a so-called vendor lock-in, so you have to buy always components from the same vendor instead of that you have the freedom to connect to others. Open source software also has the advantage that it's continuously improved by the participation of a dedicated user community. In that way, new developments, also new standards, can be implemented very fast. And it's also a great opportunity for innovation, and you can contribute with your organization or as an individual. SDIs consist of different software components. The data is stored in the spatial database, such as PostGIS, PostgreSQL. There's a map server for publishing the data, such as GeoServer. And the interface for visualization of the data, we can use, for example, Django for content management and open layers to serve the data layers. And there's a catalog with the search engine to look into the metadata provided with the data. For example, through PyCSW. The software components that are mentioned here are all open source, and they are used in GeoNode, which is a software stack for SDIs, and completely open source. Until now we have covered spatial data infrastructures, open standards, and open source software. In the next video we are going to look at metadata and quality assurance